This lesson covers the definition of inverse functions and includes a few examples of finding inverse functions. Suppose f and g are two functions such that g composed with f of x equals x for all x in the domain of f, and f composed with g of x equals x for all x in the domain of g. Then f and g are said to be inverses of each other. The functions are said to be invertible. Note that a function f is invertible if and only if it is one-to-one. This is why we discussed one-to-one functions prior to finding inverses of functions. Also note that the inverse of a function is unique. Only one inverse exists for those functions that do have inverses. Let's next find the inverse of f of x equals 2 plus the cube root of x minus 4. I'll start by renaming f of x, calling it y, and then I want to swap the x's and y's in my equation, which gives me x equals 2 plus the cube root of y minus 4. I want to solve for y here, so let's subtract 2 from each side. And then cube each side, which will result in x minus 2 cubed equals y minus 4. I'll add 4 to each side, giving me x minus 2 cubed plus 4 equals y, and then I will actually rename this as f inverse of x, and if we expanded the x minus 2 cubed and added 4 to that, we would have x cubed minus 6x squared plus 12x minus 4. You can try that on your own if you like. Next, let's find the inverse of g of x equals 2 over x minus 5, beginning by renaming g of x, calling it y, then swapping the x's and y's, so I will have x equals 2 over y minus 5. I'll start by getting rid of this fraction on the right side, multiplying through by y minus 5. On the left-hand side, I'll have x times y minus 5. On the right-hand side, I'll have 2. And then I want to get rid of the fraction, or get rid of the parentheses, so I'll distribute the x through. That gives me xy minus 5x equals 2. Remember, we're solving for y, so let's isolate the xy term on the left side by adding 5x to each side, and then divide through by x. We get y equals 5x plus 2 over x, and this is our inverse function. The only thing left to do is call it f inverse of x. Whoa, I'm sorry, this should be g inverse of x. G inverse of x equals 5x plus 2 over x. Okay. Next, we'll show that g of x and g inverse of x that we just found truly are inverses. To do that, we need to find g composed with g inverse of x, and that would be the same as g of g inverse of x. I'll substitute for the g inverse of x, I'll substitute 5x plus 2 over x, so we're finding g of 5x plus 2 over x. In my equation for g of x, where I have an x, I'm going to replace that with 5x plus 2 over x, and then we'll simplify. I'll get one fraction in the denominator, 5x plus 2 minus 5x over x. The 5x minus 5x adds to 0, so we have 2 divided by 2 over x, which is the same as 2 times x over 2. That simplifies to x, and that's what I need to get to show that g and g inverse are inverses. But we also need to go from the other direction. We need to show that g inverse composed with g of x is equal to x as well. So we'll find g inverse composed with g of x, which is equal to g inverse of g of x. Here for g of x, I'll substitute the 2 over x minus 5. To find g inverse of 2 over x minus 5, wherever I have an x in g inverse of x, I want to replace that with 2 over x minus 5, and then we'll simplify. In the numerator, I'll take 5 times 2 to get 10, and I'll get the 2 over the denominator of x minus 5 by multiplying it by x minus 5. So we can simplify a bit. Notice that we have 10 plus 2x minus 10, so I'll have 2x in the numerator over x minus 5 divided by 2 over x minus 5. And that's equal to 2x over x minus 5 times x minus 5 over 2. We can cross out some stuff here, and we're left with x. So g inverse composed with g of x is also equal to x. That shows me that the inverse that we found is a correct inverse. Next, we'll find the inverse of h of x equals x plus 3 over 2x minus 1. Renaming h of x as y, I'll swap the x's and y's. So x equals y plus 3 over 2y minus 1. We're solving for y. I'll start by getting rid of this fraction, multiplying both sides of my equation by 2y minus 1. And that's equal to y plus 3 then. So we get rid of the fraction, then we'll get rid of the parentheses by distributing through the x. 2xy minus x equals y plus 3. We want all the y terms on the left side, all the terms without y's in them on the right side. So 2xy minus y equals x plus 3. And then I want to factor out the 2x minus 1 from the two terms with y, and finally divide through by 2x minus 1, so we get y equals x plus 3 over 2x minus 1. This is our inverse, so this is h inverse of x equals x plus 3 over 2x minus 1. Try on your own. Find the inverse of f of x equals x plus 5 over x minus 3.